Hello everyone, welcome back. We're just continuing our conversation with definite integrals, and now as you guys can see here, we have a lot of properties that you guys can do with definite integrals. And so instead of me just going over them here on the screen, I'm just going to do some examples of them. So we're going to talk about them actually in the problems themselves. So like I said, one thing I just want to say really fast about this one right here, number one, is that this is going to be part of the fundamental theorem of calculus. So this one will really focus more on in the next lesson set. So for example number 6, it says it is known that the integral from 1 to 10 of f of x dx is equal to 4, and the integral from 10 to 3 of f of x is equal to 7. Then what's the integral from 1 to 3 of f of x? So what I have students do here is we have to look at the relationship. So this is an overall, right? So 1 to 10 is the overall. And then we have a 3 to 10 and we have a 1 to 10 or 1 to 3. So when I write this out, what I tell students to do is that we always start with 1 and 10 of f of x dx. And we always want the smaller number. We want the smaller number to be on the bottom. All right, we're going from 1 to 10. This is how we've always written it, right? It's always from A to B. So this is going to be equal to, and this is one of the properties at the very top of the page, this is going to be equal to 1 to 3 of f of x dx. And then we can add, so basically, I always say it like this, just normal basic stuff. We're on a road and we're at mile marker 1 and we want to walk to mile marker 10. Well, the first thing is we can walk from mile marker 1 to mile marker 3, and then we have to walk from mile marker 3 to mile marker 10. And so this is very similar to that and actually a much easier way of doing the problem. So it's 1 to 10 equals, and again, notation, is equal to 1 to 3 to 3 to 10. So now we actually start plugging in what we know, right? So we know that the interval from 1 to 10 of f of x dx is actually equal to 4. So we can go ahead and substitute that in as 4. We're trying to figure out what this is. We don't know what this is. So this is going to be from 1 to 3 of f of x dx. Now, our issue here is that we want the interval from 3 to 10 of f of x dx, but we were given the interval from 10 to 3. Well, this is actually very easy to do because there's an identity at the top of the page. So what we've actually done so far is we've looked at this one right here. We've looked at this one right here. And so one of them that's actually not up here, which is surprising to me, in my notes here, is we can actually flip-flop it. So if I want to go ahead and write that this is going to be from 3 to 10 f of x dx, then all I have to do is change the sign. I want to change the sign of it. Okay, and again, once we start getting into more examples, you guys will see this makes more sense to you as well. So now I know that's negative, and this little piece right here, this little puzzle piece right here, we know that this is actually equal to 7, right? It's equal to 7. So I'm going to go ahead and erase this and replace it with 7. So we're going to get rid of this piece right here, but remember, we're keeping the negative part in here because originally we were looking from 3 to 10. So this is going to be equal to 7. So it's minus 7. So then all we have to do now is, and this is just as simple, this example is just as simple as 4 equals x minus 7. I mean, that's what it is. We're looking for this. This is our unknown. This is our x. But because of calculus, we want to keep the notation as good, as close as we possibly can. So we're going to say, instead of saying x, we're going to say that the integration from 1 to 3 of f of x dx is simply equal to 11. And that's going to be our first answer. Okay, so we're going to do that question like so. So what do we get out of that? So as long as you guys realize the way it's written, the number that's here and the number here have to be the same thing. So that's exactly why the 3 that's written right here has to equal to 3 right here. And then the interval we're looking at, A to B, have to be here and here. I could have absolutely split this up again. I could have went 1 to 3, and they'll say 3 to 7, and then 7 to 10. I can have as many integrals as I want to as long as the smallest number, the one here and the one here, is the interval, and then these numbers here have to match up. So that's all this example right here is. And so I'm going to go ahead and put in the notes because I don't know where it is. It's probably somewhere right there, and I'm just not seeing it. But if I look at a to b of f of x dx, and that's really horrible to say, if I'm looking at that, that's going to be equal to negative ba of f of x dx. Some of you are probably like, it's probably the step that's right above, and so I'm just not really seeing it right this second. So yeah, that's it. So let's move on to the next example. Okay, guys, so example number 7 says use property 8 to estimate the value of 1 to 4 of the square root of x dx. And so I have already here underlined for us what we're going to use. All right, so we have this m times m b minus a, and then this is the integral that we're actually approximating, and then the big M of b minus a. So we're going to go ahead and just put right here in the middle, right? So we're going to do less than or equal to our integral. So a is going to be 1 and b is going to be 4. So we're going to go ahead and say a is 1 and b is going to be equal to 4. And that's given to us, and that's what we've already talked about previous examples that are in the interval from 1 to 4, and this is a to b of our function. And I'll tell you guys again, this is not going to be an answer that you're going to use this theorem for. It's very uncommon to use this theorem for this because fundamental theorem of calculus really does tell us what this answer is going to be. And so we're going to go ahead now and keep going with this. So both to the left and to the right, we have b minus a, right? So we have 4 minus 1 on this side, and we have 4 minus 1 on this side. So the only thing that we need to clarify here is what are the little m and what's the big M. Well, this is actually very easy to do. So little m is just simply going to be what f of a is. So plugging this number into this function. So f of a, and so for this example, it's going to be what is f of 1, which again would be the square root of 1, which is 1. So our little m is going to be 1, and our big M is going to be what is f of b. In this case here, we're going to plug in 4. We're going to plug in 4 to our equation, so it's going to get the square root of 4, which is going to be equal to 2. So this is going to be 2. And so we just simplify. So this is going to be 3. And this is going to be the integration of 1 to 4 of the square root of x dx. And this is going to be 6. So we know that the value, the actual value of this, and again, fundamental theorem of calculus is what we're going to use for this, but the fundamental theorem is going to tell us what it is. Well, we know approximately it's in between 3 and 6. And when we actually evaluate this, we're actually going to just find the average of these numbers, because it's going to be, it's not necessarily in the middle, but it just gives us a good approximation. So it's going to be 9 over 2, so it's approximately 4.5. It's approximately 4.5. And so you guys can use your calculator to plug this in, or you can wait to the next lesson where I teach you the fundamental theorem of calculus and find what the actual value is. So it's just another way of approximating an integral without knowing what to do with it. Look at example number 8. And example number 8 says we're given the piecewise linear function f, which is right here. All right, so we're saying that this is actually f of x. And it's telling us on the interval from -1 to 4, and we want to find the value from -1 to 4 of f of x dx. So this goes back to a question we just did on the first video, or video number 3, where we want to find this integral. So we want to find the area underneath the curve, and again, we always want to bound it. We always want to bound it with the x-axis. So what we're looking for here is the area of this, and then the area of this. Okay, we want the area of these two things together. And so what I'm going to do here is I'm going to actually put two things together. We're going to first of all say, we want to do it by shape, right? So yeah, you guys can see that there's a triangle here, there's a rectangle, and a triangle. And yes, you can split this shape up into 3 different intervals, or you can say, oh, this is just a trapezoid, right? It's a trapezoid. So the integration from -1 to 2 of f of x dx, and if all this is going to be equal to the area of that trapezoid. The area of the trapezoid. And then I'm going to add, and so this is going to be 2 to 4, and again I'm using the theorem that we just did in example 6 of f of x dx, and that's going to give me the area that I want, and this is going to be the area of the other trapezoid. So this is going to be the second trapezoid, this one right here. And this is going to give me the interval from -1 to 4 of f of x dx. So that's all we have to do to solve the problem. Now, I want you guys to notice that one of them is above the x-axis and one of them is below the x-axis. So we're going to come back to this in a minute. Let's find this first one, because that one actually is pretty easy to do. We have, again, that this area for the first one, so I'm going to go ahead and say that the integration from -1 of 2 of f of x dx. So let's go ahead and find this one first. And it's going to be equal to 1/2, because again, area of a trapezoid is 1/2. And then our height of our trapezoid is simply going to be 2. Right, the distance from the top base to the bottom base, the distance between the two, is going to be 2. And then we're going to add our bases. So this base right here, 1, is going to just be from 0 to 1, so this is going to be 1. So it's going to be 1 plus, this base is going to be 1, 2, 3, plus 3. And so we're going to get 4 times 2 is 8, divided by 2 is 4. So this first part right here is going to be 4. So I've got 4 for the first one. And I'm going to go ahead and put a little 4 right there. Plus. Now, from 2 to 4, guys, this is what we have to understand about this one. So we're going to go ahead and change the color up for us for this one right here. So the area of this trapezoid, we're going to go, so the integration of, I just write so big. So from 2 to 4 of f of x dx is equal to, so it's going to be 1/2 again, but now our height is actually going to be -1. We're going in the negative direction, So our height's going to be this way. So it's going to be -1. And then our base is going to be 1 plus our base is going to be 1, 2. And so we're left with 2 plus 1 is 3. 3 times -1 is -3, -3/2. So this is going to be equal to -3/2. This is going to make so much sense when we get much further into this course and we talk about area and volume of rotation, where you guys understand that technically y is something underneath the x-axis negative. And that's really what I want you guys to come out of this lesson knowing, is that anytime you're finding the area underneath the x-axis, it's going to be a negative value. So this is always positive and this is always negative. And like I said, you guys will have a true appreciation for that when we actually, when we get to that part, which I think is unit 5 or 6. But it's pretty far down the road. But anyways, so this is going to be -1.5. So 4 plus a -1.5. When we add these things together, then we're going to get that this is going to be equal to 2.5. And so our answer here is going to be B. So area above the curve is going to be positive. Area below the curve is going to be negative. Now technically area cannot be negative, but it's going to have a negative value. It's going to have a negative value. And so again, we used the rule at the very top to show you guys this. We are looking at our interval from -1 to 4, -1 to 4, and then these numbers here are the exact same. So 2 and 2. And again, -1 to 2, 2 to 4. It gets us from -1 to 4. All right, so I hope that video makes sense to you guys as well. We have one more left to do for integrals, and we'll do that next.